we're going to do an activity to help us learn how to classify our numbers. For this activity, you simply need a piece of paper, blank computer, notebook, I don't care, you just need a piece of paper and turn it horizontally like this one is. You will need a normal pencil and 4 colored pencils. So go ahead and pause this video so you can go get those things. Now that you're back with those things, what we're going to do is take our piece of paper and across the top, we're going to write real numbers. Just in my normal pencil. So what this means is in our pretend world right now, this entire piece of paper represents the entire real number system. So any number that would be on this piece of paper is going to be considered a real number. Again, real numbers are basically all the numbers you know. Fractions, decimals, positive, negative, rational, not rational, whatever it is. And they fit, all of them in our pretend world fit on this piece of paper. So what we're going to do next, pick whatever color you want. I don't care. I'm going to go green first. What I'm going to do is draw a box that is just inside of this. I'll show you. It's going to be similar to that video you watched. So it looks like this. So it's almost as big as the whole piece of paper, but not quite. Okay? It kind of borders it, but there's definitely room. And what we're going to call this, what we're going to write across the top of this box, just inside of the box, in green, I'm writing whatever color you have, is rational numbers. So it looks like that. So all the numbers that fit on the piece of paper are real numbers. All the numbers that fit inside my green box, whatever color you have, are rational numbers. The reason we drew the box so big is rational numbers take up a big part of the whole number system. They're a big chunk of the real number system, but they're not everything. So there's this border over here of numbers that are not rational that I could still write on the real number system. Okay, and those are the ones that we don't really worry about this year. But rational numbers are a big chunk of the real number system, so anything that fits inside the green box is going to be considered a rational number. Now, green one down. We're going to pick up the next one. I'm going to do red. I like Christmas. Okay. Inside of the rational box, I'm going to draw another box. Just like that. So again, it takes up a good number of the rational, but it is smaller and it's inside of the rational number box. I'm going to title that one integers. You probably know where this is going. That means anything that fits inside the red box is an integer. Because the integers are inside of the rational number box, anything in the red box is also considered a rational number because it's inside of it. So anything I write in the red box is inside the integer box, so it's an integer. It's inside the rational box, so it's a rational. And it's on our real number piece of paper, so it's also a real number. Next, pick your new color. We're going to do a box inside the integers box. And we're going to title this one whole numbers. So it looks like this. As you can see, whole numbers are type of integers, are type of rationals, are type of real numbers. So any number that fits in the whole number box is also in the integer box, so it's considered an integer, is also a rational number, and of course is on the paper, so it's a real number. Last colored pencil, we're going to draw another box inside of that one. And we're going to title this one natural numbers. So that it looks like this. So anything that fits inside the orange box for me is a natural number. If it's a natural number, it's a whole number. If it's a whole number, it's an integer. If it's an integer, it's rational. If it's rational, it's real. Okay? So now we're going to pick up our pencil and let's pick a number. Let's pick the number 5. Which box does 5 go in? Well, it's a counting number. It's natural, so it goes in the natural box. So the number 5 is in the natural box. It's also in the whole numbers box. So 5 is also a whole number. It's also an integer. It's also a rational number. It's also real. The number 0 is a good one to put down. Remember in that video, when we count, we don't start with 0. I don't have you guys stand up and go 0, 1, 2, 3 students. I start with 1. So 0 is not a natural number. I will not write it in that box. However, it is a whole number. So I will write it there. So it is not in the natural box. It's not a natural number. It is in the whole number box. So it's a whole number, which means it is also an integer. It is also rational, and it is also real. It would fit in all 4 of those number systems. Okay? That's the only number. 0 is the only number that will be in the whole box that's not in the natural box. Let's pick another number. Let's do -10. -10 is an integer. Okay? Natural numbers do not include negatives. Whole numbers do not include negatives. So -10 is an integer, which means it's rational and real. -10 only fits in 3 number systems. Okay? Now, how about the number -1.3? Where does -1.3 go? Well, natural numbers don't allow you to have negatives. Whole numbers don't allow you to have negatives. I can have negatives with integers, but I cannot have decimals. So just because it's negative, it does not go with integers. -1.3, because it's a decimal, doesn't fit until it's a rational number. So -1.3 would be in the rational number box. So now you can use this diagram to, if you think of a number, think where does it go? Does it fit the definition of a natural number? Yes, it does. It goes here, you can stop. It's a natural number, it's whole, it's an integer, it's rational, it's real. If you look at the number and say, well, it doesn't fit in the natural number box. It doesn't. Okay, it doesn't fit in the whole number box. Okay, it's an integer. Now I can put it there, and then it's automatically rational and real. And you just have to think of what the definition is. Natural numbers are our counting numbers. There's no 0, no negative, no fraction, no decimal. Whole numbers allow us to have 0, but there's no fraction, no decimal, no negative. Integers allow negatives, but still no fractions and no decimals. Rational is now the first time we can have fractions and decimals with negatives and positives. There's still positives in here. And then, of course, they're all real numbers.